about the tape. We don't care about the time.
Thank you. The Adolphus Band. Now the students are going to move the drums out of this hall just in these next few minutes, right? Because there's a concert tonight, if you'll notice on the next page of your program at Christ Chapel. And this is the time for us to get the drums out of here and over there. Dr. Nimmel will be conducting the Gustavus Band tonight in an hour program. The fanfare for the Common Man of Aaron Copland. And then 3 sections from 3 movements from Gustav Holst's The Planets. Mars, the bringer of war. Venus, the bringer of peace. Jupiter, the bringer of jollity. There is a narration that will go with the planets tonight. Poetry of Dr. Ledbetter of California Lutheran College, and then some of the poetry adapted by myself in memory of Eugene Schumacher. So that the third section, Jupiter, will be dedicated to Dr. Shoemaker. We'll call up then the principals for this afternoon's lecture. We felt very honored as we put together this program that we would have in your presence the major directors of both the American and Soviet space program. Dr. Segdeev did come to America in '89 and became distinguished professor of physics. But prior to that, as Dr. Potts will tell you, he was a director of the Russian space program, certainly a key figure in it, and to bring Dr. Stone and Dr. Segdeev together, we thought that was magic. And now, once again, the chairman Chuck Niederreiter.
Thank you. It's my pleasure to introduce to you this afternoon my colleague from the Department of Chemistry, Professor Lawrence Potts. Dr. Potts has been at Gustavus since 1972 and has been involved in many of these Nobel conferences. Most recently, he was the chair of the 1995 Conference on Material Science. He also finds time to write satire, some of it about space. Professor Potts will introduce our next speaker, Dr. Roald Segdeev.
Well, you never know what they're going to say. Welcome back after lunch. Apparently July is back with us in Minnesota. Roald Segdeev comes to us today from the University of Maryland, where he is Distinguished Professor of Physics. But his journey in life has been much farther than that. Born in Moscow, he graduated from Moscow State University and worked at the Institute of Nuclear Physics in Novosibirsk, a college town in Siberia, much larger but only slightly colder in winter than St. Peter. We all learned this morning that Mars is even colder. In that phase of his professional career, he was a plasma physicist studying the creation and control of high-energy plasmas such as those encountered in nuclear fusion reactors. In the 1970s and 80s, he was professor of physics at the Moscow Physico-Technical Institute and served as director of the Institute of Space Research. As an academician, he has published over 150 scientific articles. His fifth book, perhaps the most readable to non-physicists, The Making of a Soviet Scientist, was published in 1994. For a period of about 20 years, Professor Segdeev was among the top decision makers in the Soviet space research establishment. Under his directorship of the Institute of Space Research, there were many dramatic advances in space exploration, including the Venera series of probes to explore Venus and the satellite encounter with Comet Halley. He had access to the highest levels of Soviet leadership, including his role as summit advisor on space and arms control to Mikhail Gorbachev during the period of perestroika. Among his many awards are the Lenin Order of the USSR for scientific achievements and the Lenin Prize. He told me at lunch with great pride that he's also a member of the Swedish Academy of Sciences. Professor Segdeev is well known within the international space community as a bridge builder and was devoted to fostering understanding between the superpowers. He even had a brief career as a politician, serving on the last Supreme Soviet in 1987 and in the Congress of People's Deputies of the USSR in 1989. Professor Segdeev is a warm and engaging person. Last night, after supper, I drove him back to campus in my 10-year-old Ford station wagon, which my family affectionately calls the land barge, for you Star Wars fans. He said to me, "This is a great American car. It reminds me, however, of the Mir space station." Should you patch it up and drive it another 40,000 miles, or get rid of it and buy a new one? Please welcome Roald Segdeev, who will speak today on new horizons for solar system exploration.
Thank you, Larry, for warm words. I'm thrilled to be here with you. The only disappointment is that I was promised Russian weather here, but I found Washington East Coast weather. The history of solar system exploration cannot be separated from the history of the Cold War. It is competition between two superpowers which fueled essentially the space race, and in a quite ironic way to help scientists on both sides of the ocean to get good projects approved to run all of their sophisticated spacecrafts flying to different planets or other bodies of solar system. It is amazing how superpowers during the Cold War managed to divide the spheres of influence inside solar system. You must remember that Ed Stone tactfully omitted mentioning of Venus in his morning speech. The gentleman agreement was that United States control the god of war, Mars, and Soviet leaders thought that Venus is a goddess of love, goddess of peace. So we were watching each other very carefully, and in many instances we were coming together for almost clandestine meetings, scientists on both sides of the ocean, to discuss how we really could create international climate of collaboration, of complementary approach. And I think we achieved this spirit of cooperation long before Gorbachev and Reagan signed important treaties which virtually ended the Cold War. When Venus was the only target left for Russians after huge successes of American space program, first with landing men on surface of Moon, then landing sophisticated robotic spacecraft Viking lander on surface of Mars. So we saw that Venus probably is the only one which now left for us. And what we have discovered, and we started our missions, that even if she was considered as a goddess of peace and love, the environment in atmosphere of Venus and on surface of Venus was really extremely hostile. Soviets started to launch spacecrafts to Venus in early 60s. The first spacecraft just flew close to Venus, taking a very instantaneous, simple image of Venus. Next one came closer to atmosphere. At that time, when first Soviet Venera, is a Russian name for Venus spacecrafts, were coming to the vicinity of the planet, there was a very little idea how hostile is environment on Venus. We didn't know where the atmosphere of Venus ends because its atmosphere and its surface very close from human eyes and telescopes by a thick layer of clouds. And the first Soviet lander, which was launched in 1968, came to the altitude which later was discovered there was only 18 kilometers above the actual surface of Venus. And then it collapsed. Soviets were extremely ingenious in finding excuses for the failures in space. So one of my colleagues suggested that we had such a huge luck. We were able to hit the peak of highest mountain on Venus, 18 kilometers. Our friends from Jet Propulsion Lab remarked that probability of such unusual encounter would be tremendously low. And then, of course, we produced counter-argument. Known from the history of early World War II, the very first Nazi bomb thrown on Leningrad, now again St. Petersburg, got on the elephant in the zoo and killed him. So gradually, one mission after another, in 1975, it's almost the time when Viking started its mission to Mars, Soviets had a very first successful landing on Venus. And despite the series of mishaps which led to this final success, it was outstanding achievement for its time, even for a very simple reason of hostility of environment on Venus. Unlike our own planet, the temperature on the surface of Venus is approximately about 1,000 of Fahrenheit. It's close to 500 Celsius degrees. So no chance to find any trace of life, no chance to find any liquid water, but we were hoping for a lot of water vapors. To keep the lander on the surface of Venus alive, even for a brief moments, for about 1.5 hours, required the best Soviet engineers to design very sophisticated lander with very interesting, ingenious way of thermal insulation. So all the electronics, all the onboard computer could be kept for a certain time at almost at the room temperature. Let me start with the slides to bring you back to these particular moments in history of space exploration. So these are two first panoramas which were taken by Soviet landers Venera 9 and 10 in the fall of 1975. The artifacts you see at the right bottom side of photographs are parts of the lander specifically used to calibrate the colors. But you see natural colors. Everything looks so dark, brownish on the surface of Venus, not only because its temperature is so high, but mostly because also its atmospheric pressure is tremendous. It's very close to about 100 times of the atmosphere close to the surface of our own planet. Still, the spacecraft survived. Now I will show you after a couple of more. You see the color markers which were used to calibrate the final colors on the surface of Venus. The spacecraft itself, it's shown on the left side of the slide, was a heavy spacecraft originally developed by Soviet space program for exploration of Mars and switched on to Venus as a part of gentleman agreement with NASA. On the right side, you see the picture of the lander. It is very different from Viking lander because it had to survive tremendous 100 atmospheres pressure and extremely high temperatures. And another interesting feature of this particular lander, it did not need any sophisticated air braking at the moment of touchdown because the density of atmosphere was so high. It was essentially descending almost like body scarf descending to the ocean floor. The only, oh, sorry, let me bring it back. The only specific precaution was taken by Soviet engineers. They built a kind of metal miniskirt which provided for stability and replaced a parachute during last stages of the descent. This basic design was successfully used by my institute in Moscow, by scientists, several times, beginning with 1975 until 1985. We had about 7 or 8 successful landings on the surface of Venus, using practically the same engineering design and moving from one launch to another to use more and more sophisticated scientific instrumentation to find out what is the structure of the atmosphere of Venus, what is the chemical composition of the soil on Venus. So this slide summarizes the major findings which resulted from numerous ground-based astronomical observations of Venus, complemented with direct space missions. Number of them were Soviet Venera missions, and there was also a remarkable contribution of American Pioneer Venus spacecraft, which had discovered a lot of data about the chemistry and circulation of atmosphere. What kind of message we can get taking a detailed look at the atmosphere of Venus? At first sight, amount of solar radiation, solar insolation energy, which is reaching the deep atmosphere of Venus, is about the same as the amount of energy our planet gets from the sun. The fact that Venus is somewhat closer to the sun is completely compensated by a huge effect of reflection of solar radiation by the top layer of very thick clouds on Venus. And yet, despite of expected balance, similar balance of energy, Venus is much hotter. The reason is greenhouse effect delivered to the extreme. The main constituent of the atmosphere in Venus is carbon dioxide. It happened to be to happen in evolutionary way, in the natural way, without the influence of any living creatures. But it tells us a lot what could be the extreme case of greenhouse effect, to what kind of climatic evolution can, in principle, take place on our own planet if we are not going to be careful. Another interesting feature of the atmosphere of Venus is the clouds in its atmosphere, which were observed by astronomers since the late 18th century. They are not made of water drops. They are not having much of the water molecules. It was a big mystery until about 20-25 years ago. Astronomers came to conclusion that it is largely made from the tiny drops of sulfuric acid. Imagine such a hostile environment for any kind of space exploration. And later in several of these missions, our chemical instruments, mass spectrographs, gas chromatographs, and X-ray spectrometers helped to confirm that it is indeed largely made after drops of sulfuric acid. Another major mystery associated with the atmosphere of Venus was the unusual dynamic, unusual pattern of circulation in the atmosphere of Venus. It was discovered first by ground-based astronomers. There was a hint that there is a tremendous circulation in the clouds. The whole cloud system represents by itself a giant global planetary size cyclone. Venus, as a solid body, always is looking to our planet with one and the same side. So its day is about 250 days on the Earth, very slowly rotating. And atmosphere impatiently self-generated tremendous cyclonic motion, which actually rotates upper layers of atmosphere in about 48 hours. The next step in exploration of Venus was to figure out how we can get confirmation about such tremendous circulation of the atmosphere. On Earth, it's very easy. We have meteorological satellites, weather satellites, which show the image of the clouds moving. In Venus, the layer of clouds is such uniform, it's such thick, you would not see any specific details to follow their evolution in circulation. So the most natural way looked to be to launch a weather balloon in the clouds of Venus and follow its motion. So the idea of launching weather balloon came to our French colleagues, and the original idea was that it would be French-built balloon. Remember brothers Montgolfier? In 1783 they were the first humans flying in the balloon in our own terrestrial atmosphere. So idea was now unmanned balloon would commemorate 200th anniversary bicentennial of Brother Montgolfier. And nothing is so simple in space program. Sometimes cuts in budget are coming unexpectedly. So finally, such weather balloons, two of them were built by Russians, and they were quite tiny. The size of the balloon, you see it here, is probably was the size of this screen. It's about 3 meters in diameter. And we had to carry special pressurized tank with helium to fill up the balloons with helium. All the plumbing was made to such sophistication that final filling of the balloons with helium took place in situ already after delivery to the atmosphere of Venus. So these balloons were released from the lander, and they were flying at the altitude of about 50 kilometers over the surface of the planet. To follow their motion, we invited huge international collaboration of radio astronomers and deep space networks to receive radio signals from the balloons, and simultaneous reception of the signals from balloons by the groundwork network of radio telescopes, using the principle of interferometry, so familiar from optics, helped to create tremendously accurate instrument to follow movement of balloons. Each balloon out of two were flying for about 50 hours, and they made almost complete circle, participating in general circulation of the atmosphere. The accuracy of measuring positions of balloon from the interplanetary distance between Earth and Venus with the use of this sophisticated instrument was about few kilometers, so with such accuracy. And to a certain degree, this balloon, you will see it here on the right lower corner of the slide. Was the first prototype, early prototype of a very small spacecraft. The small spacecrafts now are becoming a motto not only of NASA, faster, better, cheaper, but also motto of the international space community. So this particular diagrams explains how the whole scenario of re-entry in the atmosphere of Venus, of the lander, separation of number of parachute systems. It's altogether here we used about half a dozen of different parachutes. At every stage of deceleration, a different type of parachute, and then it was finally we released the balloon, which was filled with helium and got up to the altitude of 50 kilometers. To give you an impression how small was a balloon as a flying spacecraft or aircraft, flying craft, I can tell you the total mass of the payload, of the gondola of the balloon, was about 6 kilograms. So it's like a notebook computer. And out of these 6 kilograms, we had to spend almost half of the mass for lithium batteries to provide, to feed the scientific instrumentation, and most importantly, to feed radio transmitter, which had to transmit, we didn't know, balloon would never know where is the Earth. It is unoriented object, so we had to emit in every direction, hoping that some fraction of energy would be picked up by radio telescopes on Earth. The total power of radio transmitter here was about maybe 6 watts. It's just almost like a candle. And still, about a dozen of radio telescopes got very clear and very distinct signal. And the very first signal which we got in summer of 1985 was in Pasadena, near Pasadena in California, with a deep space network radio dish of Jet Propulsion Lab. So we first heard about success of the injection of the balloon from our friends across the oceans. Another feature of this particular experiment was that we had an interesting set of very simple, tiny instruments. And if you remember, this morning, Phil Morrison asked Ed Stone whether Mars Pathfinder could be equipped with simple microphones. We had such instruments here. We had mics, we had flash detector, hoping to detect lightnings in the atmosphere of Venus. The results were not yet very clear. As a matter of fact, talking about Cold War competition and the two sides watching carefully each other, I was going to ask Ed the question, are you sure that KGB did not plant mics on Mars Pathfinder? Maybe we still would get some data after another 50 years. So the whole arrangement for delivery of the balloon to atmosphere of Venus was a part of larger international operations. We had a spacecraft which was launched. Here you see arrangement of the evolution of trajectory after spacecraft was launched from the Earth. First, it came to Venus. It delivered to Venus a lander. I described before similar lander with the miniskirts, and it also delivered the balloon. And then spacecraft was very fortunate. The approach distance to Venus was selected in such a way that gravity field of Venus could provide assist, a boost to the spacecraft, which could continue to fly further. So the next destination for the spacecraft, that mission was called Vega, was a Halley's Comet. The Halley's Comet campaign of 1986 was quite memorable. The gentleman agreement between us and American space community was that Americans would not send their own spacecraft, but they will provide huge ground support. They especially using this unique dish for radio communications, part of deep space network. But we had several other countries, newcomers in solar system exploration, who came along with the Soviet Vega mission. Soviets had two spacecrafts. You see these two close trajectories. And what you see here, you see the huge cavity in the interplanetary medium in solar wind plasma, which was created by a Halley's comet. And this particular part, which is brighter, is a part which was occupied by cometary gas and dust particles after evaporation from the nucleus. They were taken to the tail of the comet. And then here there was a tiny, tiny small cometary nucleus. Nobody knew how it looked like, what was the size of this nucleus, because in all the observations of comets throughout the history of humankind, we could see only a cloud of gas and dust surrounding and toppling this tiny small nucleus, while comet looks like a giant object, hundreds of thousands miles in size. Its actual mass is concentrated in a small nucleus. Very, very only hypothesis that maybe it could be a few kilometers size only. So the goal was, for the first time, to fly very close and to detect this nucleus, which could be, as Ed Stone in his talk told us, could be also a kind of a cradle of some organic pre-biological materials and perhaps carrier of some of the living organisms. Then there were two spacecrafts which did not approach very close to the comets. These were the first Japanese interplanetary spacecrafts called Planet A. And then the closest to the cometary nucleus is a trajectory of European spacecraft Giotto. You may remember the image of cometary nucleus, which was obtained by Giotto at a very close encounter with the nucleus of Halley's comet. But it didn't happen overnight. It required tremendous international cooperation. And the heart of the center of this cooperation, I would say the control board, was in JPL, California. DSN, Deep Space Network, was watching carefully what was happening with Soviet spacecrafts, Vegas, and what was happening with Giotto. The moment when Soviets approached Halley's comet's nucleus, the position of the nucleus of the comet, which was known with some substantial uncertainty, up to several thousand kilometers or miles, its trajectory was immediately clarified, and we were able to project its trajectory for the next few days with accuracy of 20 to 30 miles. This data from Jet Propulsion Lab immediately were transmitted to French and to European control centers, and Europeans were given a last chance for maneuver of their Giotto spacecraft. And this last cosmetic maneuver brought the spacecraft very close to the nucleus of Halley's comet. Eventually they came to the distance of about 350 miles to the nucleus. However, environment, the cometary environment, is not a friendly one. It's not that because comet provides extreme temperatures or pressures. It's because of different reasons. It's because spacecrafts are approaching the comet with tremendous velocity. The two Soviet spacecrafts were crossing the cometary area with a velocity of 80 miles per second. So it's essentially maybe a couple of times faster, a couple of thousand times faster than this infamous Mercedes in Paris. So, and this whole environment is full of dust particles. When you approach comet with such a velocity, you would immediately hit the dust particles which were released from the surface of comet with the same relative velocity. If such a particle would hit the spacecraft, it would create tremendous danger. So on my side in Russia, we tried to figure out how we can protect the spacecraft from these encounters. The simple idea would be to emulate, to create an installation to accelerate tiny particles, projectiles, up to such a velocities. But we were unable to approach even a fifth of this velocity. So the only way was to make a computer simulation. Who were the guys who could provide such an expertise on such extreme velocities, pressures developed at the encounter. I had a classmate in University of Moscow who by that time was director of Soviet nuclear weapons developer. So I called him, I said, I have a problem for you, can you help me? And later, a friend of mine, he was visiting me in Washington about a few months ago. He's still trying, but his job now is to disassemble nuclear weapons. He confessed that it was most interesting part in his later life. You know, instead of taking care of overkill of nuclear weapons, he was given a problem which actually had interesting physics and helped us to design a shield protecting the spacecraft. Similar shield was developed by Europeans. In many ways, this shield was using principles of tank armor. So the closest approach, finally we were able to resolve the comet. It's not anymore the halo of the comet, which we see from the Earth by the naked eyes or by the telescope. The halo with the size of hundreds of thousands of kilometers is everywhere around. Here we see a tiny small object. The size of it was measured. It's about 10 kilometers. It's probably only slightly larger than St. Peter, where we are here. And the details of this object very unresolvable because of tremendous screening, reflected, scattered light by tiny evaporating gases carrying dust particles. But some of these streams of the material from the nucleus clearly have a nature of jets. So at the closest approach, the Vega spacecraft approached at a distance of 8,000 kilometers. More details were discovered about the comet, but still it took a lot of efforts to do computer enhancement and what is called image processing to get out of such smeared pictures the computer-enhanced images of cometary nucleus, very irregular shaped body with the size of a few kilometers. Halley's comet had about 10 kilometers in diameter, but it was quite irregular. It was not spherical shape. So different projections here. How the Halley's comet nucleus looked in details. So the mass of such object is about 1 trillion of tons. So that means 1,000 times more than billion tons. Still, it is a very tiny object, and the gravity force it creates is very small. For example, if someone standing on the surface of such a small celestial body would be interested to reach escape velocity, probably Michael Jordan could do it without any rocket. 15 meters per second probably he could get. Now, a final computer-enhanced picture here found a way to the cover pages of magazines. You recognize here Physics Today, the physics journal published by American Institute of Physics. Then this particular arrangement explains how international cooperation to navigate Giotto spacecraft during last few days based on more precise data on the trajectory of Halley's Comet nucleus discovered by Soviet spacecrafts. So it tells how big was the error box at the beginning. It doesn't look like box, but physicists anyway and astronomers would call it box of errors. So we could expect the comet somewhere inside. And then finally, after Vega spacecraft passed, we greatly reduced it, and jet propulsion quickly made all the calculations of the new orbit, gave to Giotto team navigation, which helped come very close to the Halley's Comet nucleus. And this project had official name Pathfinder. Later we are using, JPL is using with a Mars project. It was the first Pathfinder, first example of international cooperation. Encounter with the comet took place in 1996. All these things had to be planned since 1980, 1981. Let me tell you a couple of words about the general atmosphere among scientists. When we started to think about such project, many of us said, oh no, it wouldn't work. Why? My friends in Moscow and bosses would tell, you think Americans would help us? They consider us an evil empire. Remember this word? But we knew our friends in America. Ed Stone, his professor and teacher, John Simpson, he suggested to fly very interesting experiment. Since there was no American spacecraft going to Halley's Comet, it was the only chance to carry his very interesting detector of dust particles. So I got a cable from John Simpson. He said, are you interested? I said, yes, I am. So let's meet. I thought, no, we cannot meet in the United States. We would be followed. We cannot meet in Soviet Union. We would be followed even more. So I suggested, let's meet in Budapest, Hungary. Hungarian team was part of our project, and Hungary was always considered as Hungarians themselves very joking, the jolliest barrack in socialist camp. So we had a meeting, and it launched experiment. At the final moment, of course, John Simpson had to get permission, official permission for so-called technology transfer, the hardware of his instrument. And a serious panel from different governmental agencies, including DOD, were interrogating him. And they said, look, what are you going to do if Russians would learn about your hardware? You would disclose the secrets. He said, we have an agreement that instrument is coming as a black box and would never be opened by Russians. Are you sure that Russians would not do it secretly at the very last night before the launch? But he was prepared. He said, you know what I'm doing? I'm using components which I bought in Radio Shack next corner. If Russians... if Russians would open it, it would send their technology 10 years back. Okay, let's move on. So, and then finally, Europeans got this wonderful image of nucleus of Halley's Comet from their spacecraft Jota coming at a very close distance. They probably could have even better pictures, but at the distance of about 2,000 kilometers, dust particles bombarded the telescope to such a degree it became unusable at the very end. So it was essentially kamikaze type of experiment of the mission what the Europeans undertook for Halley's Comet. So, and now let's come back to the image of the comet, which taken by ground-based telescope. What I was talking about was a small, tiny nucleus which would be never seen somewhere here inside, always covered by a layer of evaporating gas carrying dust particles. So what everyone has learned from this brief encounter with Halley's Comet, that small bodies in solar system, a part of many other features of their unusual chemistry, very low reflectivity, they are very dark. They also have a very irregular shape, and nucleus of Halley's Comet, of course, is a typical example of that. So then the next idea was to fly spacecraft to one of Martian moon Phobos, whose shape was very well familiar. It could be recorded, it could be photographed with the use of ground-based telescope. It was studied by Viking orbiters. So to continue exploration of small bodies in solar system and bringing new interesting technologies to overcome hostile space environment, we planned in Moscow a mission which was called Phobos. It was truly international mission launched in 1988, and the idea was to bring a spacecraft to very low altitude over Phobos, one of two Martian moons. So this is Mars. This is surface of Phobos. Phobos is approximately the size of the nucleus of Halley's Comet, about maybe 15 kilometers in size. And spacecraft, idea was to fly the spacecraft like a tiny aircraft at the distance of about 30 to 50 meters over the surface. And if scientific instruments would be brought so close to the surface, you can use a new type of scientific technologies to explore the composition of the material of this celestial body, which never before was used. I could call it Star Wars technology. What you see here, you see the laser beam. It was not very powerful laser, so it did not classify as prohibited by anti-ballistic missile treaty, but if it would hit the surface, it could evaporate a small sample of soil. And then this evaporated sample would go back, would explode, fly in every direction, and small fraction of it could be picked up by the instruments, detectors on board of spacecraft, and instant chemical analysis could be made by the instrument. So the instrument by itself was nothing else but what physicists call time of flight mass spectrometer. After evaporation, the light atoms or molecules would fly faster and would reach detector sooner, and then the heavier substance would trail behind. The heavier would be the atom. It would be moving slower and slower. So just by separating the time of arrival, one could easily say what was actually chemical composition, in the time sequence. So it was one of maybe a dozen of sophisticated instruments prepared for that mission. However, when spacecraft approached Phobos at the distance of about 50 miles, communication with the spacecraft was lost. We never recovered anything from spacecraft except very weak signal which helped us to understand what happened. It was a computer failure, and spacecraft did not bring us back. So the mystery of Phobos, you see, it is a dark body on the background of Mars. So much Phobos is darker. Mystery of Phobos would be still awaiting its resolution. In another photograph taken at our approach to Phobos, you see it's actually illuminated site. The Mars is illuminated and Phobos illuminated, but it's so much darker that you wouldn't almost see the details on the background of bright Mars. Another interesting experiment which awaits its implementation in future would be to bring a lander. We are going to call what we plan to bring to the surface of Phobos micro-Viking. And then the similar experiments which are done now by Pathfinder could be done on Phobos. If one would make it a movable object like a rover, it is conceivable that a robotic rover on surface of Phobos could make around the globe trip around the Phobos or any kind of small body because of much shorter distances in this case. So there were a lot of speculations about the reasons why spacecraft was lost, and one particular theory, I just xeroxed the front page of the article, relates it to the Star Wars incident. I haven't read the details, but there must be very interesting scenario suggested in this particular article. Now, I would like to use a couple of minutes of your time to tell you what could be done with Phobos, and there is also another Martian moon, Deimos, in a future scenario of exploration. Perhaps I am driven by psychology of the criminal. There is a general belief that criminals would like to visit the scene of crime, but I'm attracted to go back to Phobos. So let me switch on to the computer screen. So what you see here is the following. There is this is the Mars, the green sphere, and then there is a small spacecraft, tiny spacecraft, which could be brought to the orbit around Mars as a piggyback passenger during one of standard missions, regular missions to the vicinity of Mars. And then if this spacecraft would be equipped with a special type of engine, here, I just stopped the evolution of this picture. If it would be equipped with this engine, the jet stream from the engine is indicated by the red color. The engine which is used in this particular computer simulation is called plasma thruster or electric thruster. These are the engines of the future. JPL is planning in a couple of years, maybe even next year, the space validation of electric propulsion in one of their small spacecraft missions. Russians are using these thrusters already to control the orbits of telecommunication satellites. But this particular scenario here tells how one can fly a tiny spacecraft, 100 kilo of mass, beginning from the original capture orbit around Mars, coming to the orbit of Deimos, the smaller of Martian moons, coming very close to the surface, then landing on it, and then getting up, taking off, going to Phobos. The electric propulsion is going to be an important means of space exploration, solar system exploration in the next decade. One of the major applications of this technology announced by Japanese Space Institute, they are going to fly it to land on asteroid and then bring back the sample of the material, sample return mission from asteroid. Let me move to the next. Next slide. We are approaching a very interesting, exciting moment. For the first time, human-made spacecraft would approach and stay for a long time next to the asteroid. The very first photographs taken about asteroids by Galileo spacecraft, this is a Gaspar asteroid, indicate that these bodies are of very irregular shape. It's in a very interesting way and in very profound for the whole science of solar system origin, this type of missions associated with the problem of so-called planetary resonances. The planets interact with each other. Each planet creates additional force acting on its neighbor, and its force is not constant. This force is periodic, and often you can get in the resonance. Jupiter, for example, is believed to control nearby planets through these resonances. Small bodies in solar system, if they have such a tiny shape, they will act on nearby satellites in a very similar fashion. There could be resonance between rotation of these asteroids around their axis and periods of small spacecrafts moving around asteroids. Let me show you computer simulation of this particular situation. So to simulate irregular distribution of masses inside the body of asteroid, my colleague who designed this program used a picture of several discrete masses rotating around the center of gravity. We call it mass concentrations of masses discovered on the moon. And then you see the small swarm of tiny spacecraft, the test spacecraft, which are orbiting around this asteroid. So you see everything looks great. The orbits are stable, and there is no interaction. Let me change one particular thing here. You will recognize what I'm going to do now. After I will bring back. What I did now in this computer program, I changed the direction of the spinning, of self-rotation of asteroid. And you see what's going to happen now. Now, half of these tiny test satellites precipitated on asteroid, and the rest, were just kicked out to the infinity by this resonance between spin of asteroid and orbiting satellites. Next year, JPL would control the orbiting satellite near around asteroid. I'm sure they are going to take into account all of these intricacies of celestial dynamics. To finish, I would like to project to a distant future. What kind of spacecraft we will get in our hands to explore not only distant parts of solar system, but perhaps nearby stellar systems, with a flight time required many generations of humans on life. One of the most interesting projections was suggested by physicist Freeman Dyson from Institute of Advanced Studies in Princeton. He said, why not to design small spacecrafts like butterflies, insects in cocoon. So over the long period of flight time, they are going to be almost like in hibernation, and the moment they will start approaching destination, they will open their science instrumentation packages, prepare for real mission. Why not to use this type of concept? Don't you think that the bee is an example of such robotic, unmanned spacecraft, equipped with all the instruments? We can learn a lot how to build these scientific spacecrafts of the future, equipped even with more sophisticated imaging cameras in the natural world, the eyes of the living organisms. Thank you.
Ladies and gentlemen, we'll take about 10 minutes. You can send forth some questions.
Turn the auditorium lights up so you can see who's out there, right? Oh, sure. You're at television. Like some water?
No, thanks.
Slides there.
Oh, thank you. I'd like to take this opportunity to welcome Bob Russell, who just joined us this afternoon on this panel. Okay. Thank you. Perhaps we can begin with questions from the other panelists. Story?
Given how slow Venus rotates, once every 288 Earth days, did you ever consider sending a spacecraft to the terminators? It would have a much more reasonable environment, or to the poles?
There was some discussion, but despite of Venus showing one and the same side to the Sun over a long period, the temperature variation along the surface are very small. On the shadowy side of Venus, you will find virtually the same temperature as on illuminated. because of the tremendous thermal exchange through circulation of atmosphere.
Okay. Dr. Boss?
Yes, Roald, I guess you didn't have time to tell us about all of the successes of the Soviet space program, but certainly one of the more spectacular successes was their success with the lunar missions. I understand the Soviet space program did not plan to land a man, as the U.S. did, but really set their goal as being the return of scientific samples from the surface of the moon, which they succeeded in. Could you describe to us some of that process?
That was the greatest success of Soviet propaganda. After 3 consecutive launches of the huge launcher, N1, it had a coded name. Failed, exploded on the launching site. Fortunately, without a crew. It was a test launches. After that, Soviets, observing that Americans already are on the moon, decided that they should declare that they never intended to send a man.
Philip?
What can you say about the scaling of radiation damage effects in the brain of the space bee and so on? It's full of addressable electronics of some sort, which must get a lot of radiation from the cosmic radiation in space and the secondary electrons. Does that scale properly? I think it'll be all saturated with errors.
It is always and will be for a long time one of the important considerations. Fortunately, magnetic field of our own planet protects from the bulk of galactic cosmic rays when we are flying Mir station or shuttle or future international station in low Earth orbit. The only real danger would be during most catastrophic solar flares. And usually this eventuality is taken into consideration. There are small capsules inside the spacecraft which screened with a thicker layer of protective material. If there would be a signal from the beginning, the crew can go there for maybe 10-15 minutes of most active phase of solar flare. If, when eventually missions would be flying outside of our own planetary environment, for example, to Mars, then there is a serious issue how to protect from galactic cosmic rays. The evaluation based on the data about these cosmic rays provides the following comparison, that astronauts who would spend about a year en route to Mars and then back 1 year, they will get approximately the same dose of radiation as courageous firemen who were sent to stop a fire at the Chernobyl reactor. And you know, it was a serious issue. Many of firemen required bone marrow transplant. So there is a continuous analysis what could be done. Especially dangerous would be, again, solar flares in such a long flight. So we will see how it would develop.
But what about a very long voyage that you suggested might be made with micro spacecraft lasting 10,000 years in the galactic cosmic rays?
Oh, I think the electronics is extremely radiation resistant now.
Not that resistant.
It's, pioneers are, some of the pioneers are working 20 years maybe already. Electronics is very resistant, yeah.
A question from the audience. If the Russian solid fuel rockets are really superior to liquid fuel rockets, why don't we use them?
Oh, first of all, I have to tell that Russians, all of these big rockets, the launchers for the spacecrafts, like Proton launcher or others, they are built, they are using liquid fuel. It's this is in the area of liquid fuel. Soviet rocket engineers achieved such a degree of sophistication. And solid rockets, solid engines are used only in smaller rockets. For example, SS-25, this is a single warhead ICBM, is using solid fuel.
Questions from the audience have been about the future of manned space flight, manned exploration of the solar system. Would you like to comment on that?
I think despite of this radiation problem, nothing can stop man to stay forever on Earth. I'm sure there would be missions. There would be missions maybe in the next 20 years. And NASA, at least now, is considering this as a long-distance goal.
One last question. Why hasn't Halley's Comet evaporated out of existence by now, considering how small it is?
This is a very interesting question. If you would consider how much of material is taken at each apparition, comet spends most of the time at far distance from the sun, and there is no danger there. Then it's approaching, and during about a year, it's coming to the distance of Venus or Earth, close by to the sun. And if you would calculate how much of the ice and the dust particles would escape, it would be about maybe a couple of meters layer. So out of 10 kilometers size of the Halley's Comet, now you can calculate for how many more apparitions Halley's Comet can survive, and for how much longer it could fly if its period is about 75 years.
Okay, thank you. We'll take a break now. We'll reconvene at 3:15 with music and 3:30 with our next lecture. There will be refreshments served on the Ekman Mall in the center of campus. Everyone is invited.